Hi everyone, today we are going to talk about polar coordinates. So we're actually learning a completely different type of axis today. So everything we've done up until now, we've been using rectangular coordinates on a normal XY axis. So of course that we know that X represents horizontal movement, Y represents that vertical movement, and when we plot a point, here's X and here's Y. So polar coordinates, you have to remember, they are completely different. They no longer represent horizontal and vertical movement. Now, this first number that you see we call R. R represents what we can call directed distance. So it's essentially your distance away from the origin. All of these circles around this axis actually are your units for R. So if you want to move 1, 2, 3, 4, 5 units away, you can use those circles to help you gauge that distance. So instead of having like vertical and horizontal tick marks, now we have circular units. And this is how we can plot our R value. Now theta, we call a directed angle. And it's essentially just plotting or finding the angle just as you would on a unit circle. So this axis right here, where we know to be 0, we call this the polar axis. And this is really our starting point. And just like a unit circle, we're going to move in that counterclockwise direction to find our angle. So for example, if we had a coordinate right here, I could label that coordinate, so I count as 1, 2, 3 units away from the center, so my R value is 3, and I can see that that line represents pi over 4, because in the unit circle, right, this is pi over 6, pi over 4, and pi over 3. So that's our coordinate. A point over here in quadrant 2, how about this one right here? This coordinate, well, it's 2 units away from the center, and this would be 5 pi over 6 on our unit circle. And we can even try one like this. Now notice, even though this is going down, down is not a negative direction for polar coordinates. So this, remember, it's just a directed distance. So our distance here is just 5, and we know that this is 3 pi over 2. Now we will talk about what it means to have a negative R value. For polar coordinates, I want you to think of negative R, meaning in the opposite direction. So if I have an angle here, a negative R value would move in the opposite direction. It does not mean left or down, as negative means for a rectangular coordinate. So let's try to plot a few points on this polar axis. So this first one is at 2 pi over 3. So I know that this is the angle that represents pi over 3, and then I just go 2 units up. And here's my coordinate. For 3, negative pi over 6. So here's our starting point. Negative pi over 6 is just this line right here. And I go 3 units away, and here is my coordinate. But you might also notice it's the same exact coordinate as you see for the problem in part C. So 11 pi over 6 is all the way around going this way, and it's also 3 units away, so B and C actually have the same, it has the same point on your polar axis. So that's one thing that is definitely different from an XY axis. On an XY rectangular, for rectangular coordinates, each coordinate is unique. The only point at 1, 2 is 1, 2. For a polar coordinate, none of them are unique. We can always find another way to represent that coordinate. So let's talk about these different ways to represent them. Of course, you can probably guess that one way we can represent another coordinate for, let's say, r theta, well, we can just do a full rotation to the left or right. So we can say r theta plus or minus 2 pi. That's absolutely one way to do it. Now, another way to do it is using a negative r value. So remember, as we talked about, a negative r value means you're simply moving in the opposite direction. So if I want to use negative r, That negative r sends me exactly half of a circle away. That's exactly 180 degrees from our original point. So here we would have to add or subtract pi to bring us back to our original coordinate. So let's talk about how we can do multiple representations of this polar coordinate. So let's plot negative 3 pi over 4. So I know it's going to be right here. So I know that I can get another representation of this point just by adding or subtracting a full rotation, which is 2 pi. So I can add 2 pi to our original angle. So we have 3. And if I have negative 3 pi over 4 plus 8 pi over 4, which is 2 pi, we have 5 pi over 4, which brings us to the same place. Now let's try to do this using a negative r value. So remember, here's our original angle right here. If I want to use a negative r value, that brings us in the exact opposite direction. So notice in this case, it actually brings us in a direction where it would be positive on a rectangular axis, but remember, it means opposite. So here's where we started. It's bringing us in the opposite direction. So to bring us back to this point, I need to either add pi or subtract pi. So I can do either one, and I should be able to get an equivalent point. So I can say negative 3, and I can say negative 7 pi over 4, or I can say negative 3 pi over 4. And both of those, even though we're moving in the opposite direction, the angle has been changed to adjust for that. So remember that both of these are ways to write different representations of any polar coordinate. All right, now let's talk about how to convert from polar to rectangular or rectangular to polar. So here we actually have formulas for this, but I really want you to understand where those formulas come from. So let's consider some point in either type of axis. On a polar axis, this point we would call r theta, and r would represent this distance, and theta would represent the angle. On an xy axis, we would call this xy, and x would represent the horizontal movement, y would represent the vertical movement. So let's say we're converting from polar to rectangular. If all we know is the angle and what looks to be like a hypotenuse of a right triangle, we can find these two values using basic SOHCAHTOA. I can ask myself, okay, if I want to find the adjacent value and I know the hypotenuse, I'm going to use cosine. So I can say the cosine of theta equals x over r, and if you multiply both sides by r, you have x equals r times cosine of theta. That's where that formula comes from. And if I want to find the opposite and I have the hypotenuse, that would be sine. So I can say sine of theta equals y over r, and if you multiply both sides by r, we have y equals r sine theta. So that's where these come from. It's really just basic SOHCAHTOA. Now going from rectangular to polar, same idea. If all I have is x and y, well, one thing I need to find is this distance, which really is just the hypotenuse. This equation is just the Pythagorean theorem. A squared plus b squared equals c squared. So just remember that. Here we're essentially just finding the hypotenuse of a right triangle. Now if I want to find the angle and I know the opposite and adjacent parts of my right triangle, I would use tangent. So that's where this formula comes from. All right, so let's see if we can do some conversions. We'll do it without the formula and then check to see if the formula matches. So let's convert root 3 pi over 6 to rectangular. So it's going to be somewhere right here. This angle is pi over 6. And this distance is root 3. So essentially they're just asking us to find this horizontal distance and this vertical distance. So I can just do basic SOHCAHTOA. I can say the cosine of pi over 6 equals x over root 3. X equals root 3 cosine of pi over 6, which is our formula, r cosine of theta. And then we just simplify. Cosine of pi over 6 is root 3 over 2, so we end up with 3 over 2. And then we can do the same thing to find y. Sine of our angle is opposite over hypotenuse. y equals root 3 sine of theta, and that's our exact formula. Y equals r sine of theta. And then we can simplify this, and we should get root 3 over 2, because the sine of 30 degrees is 1/2. And then all we have to do is write it as a coordinate. So it's okay to go straight to the formula, but I also want you to be able to do it without and really understand why those formulas work. Okay, go ahead and pause the video and give this one a try. All right, so here you can see this one is actually easier to plot it and just to interpret it, although you could use the formulas as well. 2 pi is right here, and so on a rectangular axis, that's just -2, 0. Although we could say x equals r times the cosine of theta. Cosine of pi is -1, so x equals -2. Y equals r sine of theta. Oh, sine of pi is 0, so we get 0. So we get the same exact coordinate using our formulas. All right, now let's try to do the opposite. We're going to convert this rectangular to a polar. So here we have this point, -1, 1, which means this distance is -1, this distance is +1. So we need to know 2 things. We have to know what our angle is, and we need to know what this distance is. So let's start by finding that distance. This is just straight Pythagorean theorem. A squared plus b squared equals c squared. So r is the square root of 2. From there, we need to find this angle, and we know when we're finding that angle, we always use our reference angle. What we have is opposite and adjacent, so we'll use tangent. We can say the tangent of theta equals 1 over -1. Oh, that occurs when theta is 3 pi over 4. And we just need to check to make sure that this is, in fact, an angle that matches the quadrant that we're meant to be in, and it is. So our polar coordinate is root 2, 3 pi over 4. All right, go ahead and pause the video and give this one a try. All right, so here, if our rectangular coordinate is 0, 2, I can see that this is 2 units away, which means that the r value is 2, and this is at 90 degrees, or pi over 2. All right, now we're going to practice converting an equation rather than just a point. So to go from rectangular to polar, it's very straightforward. We just replace x with r cosine of theta, and we replace y with r sine of theta. Now to do the opposite, to go from polar to rectangular, we have to be a little more creative. We want to find ways to create r squared, so we can replace it with x squared plus y squared, or find ways to create tangent, so we can replace it with y over x, or find ways to create r cosine of theta or r sine of theta, so we can replace them with x or y. So these are the things we're trying to create, so we can substitute them with different forms of x and y. So let's start by going from rectangular to polar. Like I said, this one is always the same process. We replace y with r sine of theta, and we replace x with r cosine of theta. And now we just have to solve for r. We always want our equation to say r equals. So let's multiply this out. I'm going to divide both sides by r and divide both sides by cosine squared to isolate r. And now we just need to do a little bit of simplifying. I'm going to break up cosine in my denominator and rewrite it like this, just because I know that I can simplify sine over cosine to tangent and 1 over cosine to secant. And this is our polar equation. Now, as I talked about going from polar to rectangular, we need to be a little bit more creative. So look at what we're given in this first equation. We have r equals 2. So I know one of the things that is useful to create is r squared, because I can replace it with x squared plus y squared. So let's create r squared. Let's square both sides. R squared equals 4. Now I can substitute r squared with x squared plus y squared. And now I have my rectangular equation. This is just a circle with a center at 0, 0 and a radius of 2. If you actually look at the polar graph, it just says r equals 2. So all of the points where we are 2 units away, and that's just around this circle. So it definitely matches up. Now let's look at this one. Theta equals pi over 3. So we know that we like to try to create something with tangent because we can substitute that. So if theta is pi over 3, we can say, okay, then the tangent of theta is root 3. That is a true statement based on what we're given. Oh, and we know that we can substitute tangent of theta with y over x. And now if I multiply both sides by x, I just have y equals x root 3. Okay, this last one, we don't really like working with secant. That doesn't include any of our useful substitutions. So I'm wondering if there's a way we can rewrite secant. So we can try rewriting secant as 1 over cosine. Then if I multiply both sides by cosine, I get this. Now, I know that r cosine of theta is something I can substitute. R cosine of theta is always equal to x. So we just have x equals 1. This is simply a vertical line. Okay, go ahead and pause the video and give these last 3 a try. Okay, so here for part A, same idea, create r squared so we can replace it with x squared plus y squared. For question E, create tangent of theta so we can replace it with y over x. Now part F was a little bit trickier. Here we don't want to like divide by sign or divide by r, so we can actually create 2 things at once. If we multiply both sides by r, we have r squared, which we can replace with x squared plus y squared. And we have r sine of theta, which we can replace with y. Now this is a rectangular equation, but let's see if we can put it into standard form. So I see that this is probably going to be a circle. So I'm going to subtract 6y from both sides, complete the square, so I add 9 to both sides. And when I put it into standard form, I can see that this is just a circle with a center at 0, 3 and a radius of 3. All right, that is all for today's lesson. Thank you so much for watching.